Hello friend, good morning and welcome back to your favorite technical channel AVM Tech Android. Today I am available with a second video lecture related to Vapor Compression Refrigeration Cycle, widely known as VCR system. This is a QR code of my channel. By scanning this QR code you can enter into the YouTube channel, or in the YouTube you can write AVM Tech Android. You can search this channel and you can see the video. So today we are going to discuss about factor affecting the performance of VCR system. In the last video we had discussed about introduction part and working of simple VCR cycle. So today we are going to discuss about the factor affect the performance of VCR system. So friend, you can see the factors affecting the performance of VCR system include the effect of superheating, that is effect of superheating of vapor, either wet and dry compression. Second is effect of subcooling or undercooling of liquid. Third, effect of suction pressure. Next, effect of discharge pressure or delivery pressure. Next is air leakage, and final is effect of suction temperature and condenser temperature. So these are 6 different parameters on which the performance of VCR system depends. So if we find any kind of variation here, what is its effect on the performance of the system, that we have to discuss. And one by one we will start discussion about that part. So first is effect of superheating of vapor. So you can see the original cycle is 1, 2, 3, 4, 1. Now when we go for superheating, you can say the cycle is 1, 2 dash, 2 double dash, 2, 3, 4, 1. So this is our cycle. So what happens here is the RE value will increase, that is refrigerant value will increase at the cost of increase in the compression work. So compression work is increased, plus this RE will also increase. So if we talk about coefficient of performance for this VCR cycle, what we can conclude here is, you can see the effect of superheating is to increase the refrigerant effect at the cost of increase in the compression work. So this COP, that is RE divided by WC, RE will increase, WC will also increase. So in actual practice, the power consumption by the compressor is increased in more amount than the increase in the refrigerant effect, and hence the overall effect of superheating is to give low value of COP. So when we are going with superheating part, WC will increase more, and because of that the COP will drop in actual case. So friend, I hope this is very much clear to you. Now we'll go with the second part, effect of subcooling or undercooling of the liquid. So friend, you can see our cycle, original cycle is 1, 2, 3, 4. But when we go for subcooling or undercooling on the pH diagram, the new diagram is 1, 2, 3, 6 dash, 4, 4 dash, 1. So what you can see here is, by doing this undercooling or subcooling, refrigerant effect will increase with no variation or zero increase in the compression work, or you can say compression work remains same or constant. So what you can see here is subcooling or undercooling result in increase in the net refrigerant effect RE with unchanged work input of the compressor, and therefore the effect of undercooling is to increase the refrigerant effect, which in turn increase in the COP of the system. Means COP will increase. So how we can go for subcooling? So the subcooling or undercooling may be done either by circulating a great quantity or large quantity of cooling water through the condenser or using the water cooler. Then the, you can say, main circulating water, means we have to supply cold water or we have to supply the water in very large amount, and because of that what happens, COP will increase. So now the third parameter that we have to discuss is effect of suction pressure. So here is the suction pressure, we are increasing the suction pressure. So you can see the original cycle is 1, 2, 3, 4, 1. This is our cycle. Now if you will go for reduction in the suction pressure, what you can see here is the new cycle, that is 1 dash 1, 2 dash 2, 3, 4, 4 dash 1. Okay, so this is our cycle. So compared to the first one, when we will go for reduction in the suction pressure, what we can see, refrigerant effect will reduce and the amount of compression work which we have to supply, that is increase. So COP, that is RE divided by WC, so COP will drop. The reduction in the suction pressure cause increase in the refrigerant effect at the cost of increase in the compression work. The net effect of reduction in suction pressure is drop in the COP. So here COP will drop. Now next is effect of discharge pressure or delivery pressure. So this is our delivery pressure or discharge pressure. So the initial cycle is 1, 2, 3, 4, 1. And when we go for higher discharge pressure, the cycle is 1, 2, 2 dash, 3 dash, 4 dash, 1. So what you can see here is refrigerant effect will decrease and this WC value, that is compression work, will increase. So what is its overall effect? The COP will drop. You can see the same thing. The effect of increase in the discharge pressure cause increase in the power consumption to run the compressor with a reduction in refrigerant effect. So the only difference is that the effect of decrease in the suction pressure is more predominant than effect of increase in the discharge pressure, and in both the case COP will drop. Okay, so here what happens, when we'll go for increase the delivery pressure, COP will drop. Now the next important thing is air leakage. We have to prevent air leakage at all the point from the VCR system, because in the heat transfer we learned that air is a poor conductor of heat transfer. It has lower value of heat transfer coefficient, so it is reducing the heat transfer. And second, the presence of air destroys the vacuum required in the evaporator, and hence COP of the VCR system that will drop. So COP will drop because the vacuum which is maintained or vacuum which is required in the evaporator, that will drop. So we have to remove air from VCR system. This is a very important thing. The last thing which we have to discuss, that is effect of suction temperature and condenser temperature. So the refrigerant system should always be designed to operate at highest possible suction temperature and lowest possible condensation temperature, keeping the given requirements of the application in the mind. So what we have to do? We have to keep highest possible suction temperature and lowest possible condenser temperature, but we have to keep this thing in mind. That is application part. So friend, in general we had discussed different parameters which affect the performance, that is called COP of simple VCR cycle. I hope you get it, and this is a very important video regarding your internal test, your competitive examination, your end semester exam also. You have to remember what is the effect with help of pH diagram, and ultimately at the end you have to write whether COP is decreased or COP is increased with what reason. So at the end, do not forget to subscribe this channel and share this channel among your friends, among all the needy students. And important, do not forget to like this video. Again, this is a QR code of my channel, and my channel name is AVM Tech Android. So you can search AVM Tech Android on the YouTube and you can subscribe the channel. Thank you very much.